Welcome to Black Box Software Testing. Let's begin by examining the difference between black box testing and white box testing. Black box software testing is that form of testing in which test cases are created without knowledge of the internal operations of the software. That is, we're treating software as a black box into which we cannot see. Conversely, white box, or perhaps better, glass box testing is testing in which the test cases are created by actually looking into that code. That is, we now treat the code as being surrounded by a glass box into which we can see, as opposed to the black box. Which of these is better? Is black box testing a better technique for finding software errors than glass box testing? Or vice versa? The answer? Both are very useful, and in fact both are generally used in a software development project. When do we use black box testing? Well, there are at least two reasons for using black box testing. One is that we use it when we do not have access to the software code. A second is we use black box testing when we don't want to bias the test cases toward implementation. Let's talk about each of these in a little more detail. Why would we not have access to the software code? We're developing a software system, so there has to be code there someplace. Well, there are several reasons that we might not have access to the code. One is that the testers themselves might not be programmers. This can happen for several reasons. At some stages of software development, we want the actual users of the software to test it. This is the case, for example, in acceptance testing or in alpha or beta testing. In some cases, software teams include testers who are not themselves programmers. This usually happens in large development organizations. In that case, the software development team consists of various categories of people, some of whom are programmers and some of whom are testers. In a third case, there may be testers who actually are programmers. They understand coding, but they have not worked on this particular system. If it's a complex system, as many are, it would take them a long time to understand that code. Another case to consider is when one company, the client, hires another company, a contractor, to develop the software system for them. The developers will deliver the executable code, that is the machine code, so that the clients can use the software, but they won't give them the source code itself. That source code is their intellectual property and is very valuable to them. The developers may want to modify that and use it for another client, sell it to someone else. Thus, the client does not get the code itself. And without the code, they wouldn't be able to do glass box testing. Therefore, black box testing is the only testing technique available to them. Let's explore the idea of implementation bias. This is the idea that the knowledge of code can actually influence what tests we create. What's wrong with using extra information in creating test cases? Isn't it always better to have more information than less? That is it really better to test without using all of the available information? Let me explain this by looking at an example. Suppose you've been asked to create a program that represents rational numbers, that is fractions, and arithmetic operations on those fractions. Furthermore, suppose that your program works correctly on positive numbers, but you just didn't consider negative numbers. You forgot all about that possibility. Now, it could be that the code that you wrote for positive numbers works correctly for negative, but you didn't think about it when you were coding. Now, suppose you are creating your test cases based on that code. That's what we would call glass box testing. Are you likely to create a test case for negative numbers? You had forgotten them before. Why would you remember them now? This is what we mean by implementation bias. Your test cases have been biased by the way you thought about implementing this code. If we don't get to examine the code to guide the creation of a test, what information do we use? Well, there are many sources of information, documents and diagrams that are created during the software process that we can use. For example, requirements documents, specification documents, UML class diagrams, class specifications, method specifications, UML use case specifications, and even Agile stories. Each of these provides a different window on the software as it is being developed and can be used to guide test case creation. What's the appropriate level for black box testing to be most effective? It can be used as acceptance testing, system testing, subsystem testing, class or package level testing, or even unit level, that is, method testing. I think it's fairly obvious how acceptance, system, and subsystem testing can be done using black box testing. Acceptance testing is typically carried out by an organization that does not have access to the code. System and subsystem testing are carried out at a sufficiently high level that it's not reasonable to expect the testers to understand all of the complexity of that code well enough to create tests from the code. Hence, in both these cases, black box testing is most appropriate. Now, what about unit, class, and package testing? Obviously, if we're testing at this level, the code is available, and the people carrying out the testing at this level are typically the programmers themselves. How do we do black box testing at this level with programmers? A recent approach to software development has been test-driven development. The idea here is that test cases are developed first before the code for a method is created. We create these test cases from the specification for the method or the specification for the class. This then avoids implementation bias. In a later tutorial, I'll go through an example to show how test-driven development can be used for the rational number example that we discussed earlier. There are some specific black box testing techniques that can be useful in helping you to systematically test using a black box method. One of those is equivalence class testing, sometimes called input space partitioning. Another is boundary value analysis. And a third is decision table analysis. There's another tutorial on equivalence class testing that you may find useful. Thank you.